क्लास 12 में चैप्टर का नाम है सेट्स, एक्सरसाइज 1.1। ये इसका सेकेंड पार्ट है, फर्स्ट पार्ट ऑलरेडी बना चुके हैं। यहाँ पर हम क्वेश्चन नंबर 4 से स्टार्ट करते हैं। यानी अभी तक हमने ये देखा है कि हमें जैसे कोई भी सेट दिया हुआ है और हमें उसको ये शो करना होता है कि वो रिफ्लेक्सिव है कि ट्रांजिटिव है कि सिमेट्रिक है। इसी तरीके से क्वेश्चन नंबर 4 आपका जो बुक में है वहाँ पर आपका रिलेशन जो दिया हुआ है वो रिलेशन है ए कॉमा बी सच दैट ए इज लेस देन इक्वल टू बी। आपको ये दिखान शो करना है दैट इट इज रिफ्लेक्सिव एंड ट्रांजिटिव। ये आपका क्वेश्चन है, वी हैव टू शो दैट इट इज रिफ्लेक्सिव एंड ट्रांजिटिव बट नॉट सिमेट्रिक। ये आपका क्वेश्चन नंबर 4। रिफ्लेक्सिव, ट्रांजिटिव और सिमेट्रिक क्या होते हैं ये ऑलरेडी एक वीडियो में हम आपको बता चुके हैं। अभी हम एनसीईआरटी के क्वेश्चन ले रहे हैं कि हम किस तरीके से करेंगे। तो चलिए इसका सॉल्यूशन देखते हैं। तो सॉल्यूशन है कि आपका जो रिलेशन दिया हुआ है वो क्या दिया हुआ है, ए कॉमा बी इज सच दैट ए इज लेस देन इक्वल टू बी। नाउ रिफ्लेक्सिव के केस में क्या होता है, a comma a belongs to R as a is equal to a. That means if we take any value, for example 1 and 1, that means for the a we can take 1, for the b we can take 1. Then value of a is equal to b, that is 1 is equal to 1. So it clearly satisfies the condition of the reflexive nature. So this set is the reflexive. So we can say that R is reflexive. Now the second quality, second property which we have to consider, we have to check that is a symmetric, whether this relationship is symmetric or not. For this, if we take a set ordered pair like 2 and 4, it means if I say that the value of a is equal to 2 and value of b is equal to 4, then inverse of a comma b, that is a comma b becomes 2 comma 4, and if we take b comma a, then it becomes 4 comma 2. Now we will check it for the condition, that is a is less than equal to b. This satisfies the condition that 2 is less than 4. But according to here, if we check for that, it becomes like this. Now it becomes a and it becomes b. Now 4 and 2. Then it becomes 4 is less than equal to 2, which is not possible. Which is wrong. That means 4 is never less than 2. So this relationship is not symmetric. This is not symmetric relation. That means we can write in this way that we can write in this way, simply we write R is not symmetric. Now we have to check for the last condition whether it is transitive or not. Now we have to check whether this relationship is transitive or not. Now for the transitive we have to take 3 elements. So now I will take the 3 elements, the 3 ordered pairs, that is a comma b and b comma c. Now let this ordered pair belongs to the relation R. Now from here, if we are applying the condition, we can write like this: a is less than b and b is less than c. Now we ultimately check that whether a is less than c or not. So it is obvious that a is less than c. We can take one example. If we take the value of a is equal to 2, value of b is equal to 4, and value of c is equal to 6, then we can ultimately see that 2 is less than equal to 4 and 4 is less than equal to 6. And if we check for 2 and 6, 2 is ultimately less than equal to 6. 2 must be less than 6. Now from here, it satisfies this condition so that this set is transitive. So from above conclusions, we can say that this relationship is reflexive nature, it is of transitive nature, but it is not symmetric relationship. Now the next question number 5 of the exercise. I am going to explain you. Now question number 5. In the question number 5 we have a relationship of R, which is equals to ordered pair A comma B is such that A is less than equal to BQ, and we have to check whether it is reflexive, symmetric or transitive. Now I am going to check one by one. How will you solve this? Its solution. Now relation R is equal to A comma B ordered pair. That means such that A must be less than equal to BQ. Now for this, if we take a case, if we take an ordered pair like 1 by 2 comma 1 by 2, which doesn't belong to a real number. So from here we can see that 1 by 2 must be greater than 1 by 2 whole cube. That is 1 by 2, which is greater than 1 by 8. So from here, if we take the same cases, then it is not reflexive. It is not reflexive. Now I have to check for the symmetric conditions. Now if we take one ordered pair like 1 comma 2, it belongs to the real number. Now if we find out from the condition A and less than BQ, then we have to write like this: 1 is less than equal to 2 to the power q, which is equal to 1 is less than 8. So it is correct. Now if we have to check for the inverse of that, that is 2 comma 1, then we have not the square, then we have 2 which is less than 1 cube. Now from here we can see that 2 is less than equal to 1. So which is not possible. So it is not symmetric. The relation is not symmetric because it does not satisfy the symmetric nature. Because in symmetric nature, we have to show that A comma B, if A comma B belongs to R, then we have to show that B comma A also belongs to R. But here we can see that 2 comma 1 does not satisfy the condition of A is less than equal to B cube. So we can say that this is not symmetric. This is for the symmetric, this is for the reflexive. Now we are checking for the transitive nature. Now I am checking for the transitive. Now for the transitive, if we take a case like this, for the transitive case, if I take an ordered pair of example 3 comma 3 by 2, this is also a real number. So now another ordered pair I will take, because you have to take two ordered pairs, 3 by 2, and let it be real number 3 by 5. These are all real numbers. Now we have to check for them. Now 3 is less than equal to cube of the 3 by 2. So it becomes 3. That is, if we have just making the cube, it becomes 27 by 8. Now if we have check for here, 3 by 2, it is less than equal to 6 by 5. We have to cube of 2 cube, that means 216 by 125, and this 3 by 2. When we check for this, we find that 3 is less than equal to 27 by 8, because if we divide, we get 3 point something, 8 3 to 24, then point something 24, that is 30, then 8 3 is 24. So now 3 is less than 3.3, but here we find that 3 by 2, it is greater than 6 by 3. So it does not satisfy the transitive case, so this relationship is not transitive. Okay, so this relationship is neither reflexive, nor transitive, and not symmetric. Now I am shifting to question number 6 of your exercise. Question number 6. In the question number 6, we have to show that, I am just writing this question, show that relation R in the set 1, 2, and 3 given by relation R is equal to 1 comma 2 and 3 comma 1. It is symmetric but not reflexive and transitive. Now, solutions. For example, we have a set A is equal to 1, 2 and 3. Then we have a relation given in the question 1, comma 2 and 2, comma 3. This is the relation given to us in the question. Now we can see that for reflexive, we must have an ordered pair like this 1, comma 1, 2, comma 2 and 3, comma 3, which does not belong to the relation R. It does not belong in relation R. That's why it is not reflexive. Now I'm going to check for the symmetric. Now for the symmetric, we have the ordered pair like this 1, comma 2, 2, comma 1, then 2, comma 3, 3, comma 2, and then 2, comma yes. Here. Now we see that 1, comma 2 and 2, comma 1, it belongs to the relation. It belongs to the relation. So it is symmetric. Now we have to check for transitive. Now in case of transitive, we have a relation like this 1, comma 2, then 2, comma 3, then 1, comma 3. And we clearly see that this set doesn't belong to relation. So it is not transitive. Now question number 7 is a set of books, etc. This is just theoretical, you just leave that. Now question number 8, I'm going to solve for you. The 10th question. In the 10th one, you have to give examples by your own element science help in second. Now, the next important question which should be prepared by you in exercise 1.1. As I have seen here, question number 8 is an important one. I'm going to come back. Question number 8. So that set A is equal to 1, 2, 3, 4 and 5. Given by relation R is equal to relation is A, comma B such that mod of A minus B is even number. Is an equivalence relation. Now what is equivalence relation? That means any relation which satisfies all the three conditions, reflexive, symmetric and transitive, then that relationship is the equivalence relation. Here I am going to solve this. Now set A is equal to 1, 2, 3, 4 and 5. Now R is given as, we have to make ordered pair like this A, comma B such that mod of A minus B is even. we take A is equal to B, that means if we take an ordered pair like A and A, and if we solve for that, mod of A minus A, which is equal to 0. So 0 is the even number. 0 is the even number. So we can say that R is reflexive. Okay. Now, if for example, if I take 1 comma 1 as a ordered pair, now we have to check for 1 minus 1, that is equal to 0, and 0 is the even number. So we have the ordered pair of 1 and 1 from this side. So this is reflexive. First. Now second. Now I'm going to check for the symmetry. Now, for example, let A comma B belongs to the relation, and mod of A minus B is even. It is given in the question. Now, if we find the value of mod of minus A minus B, then it's because everything which we taken out from the mod, it becomes positive. So I can write it as minus A plus B, that is B minus A. So if A minus B is even, then B minus A is also even. That means, for example, if I take like this 1 comma 2 and 2 comma 1, two different order pairs. If I find, I will take 4 and 2, for example, and then 2 and 4. Then if I find 4 minus 2, value of 4 minus 2 and value of 2 minus 4, here we can see that we get 2, and here we can see that minus 2. So when we take it outside from that mod, we get plus 2. Both of them are even. So we can see that this is also an even. So that means A comma B and B comma A both belongs to the relation. So it satisfies the symmetric condition. So R is symmetric. Now I have to check for the transitive nature. Now we take two ordered pairs. For that, let A comma B belongs to R and B comma C belongs to R. So A minus B is even. Similarly, B minus C is also even. So if we check for that, A minus C. So what is its value? A minus B plus B minus C. You have to check for this. So it becomes B and B get cancelled, and B again becomes, we get A minus C. So which is even. So from here we can say that A minus C is even. That means R is 1. So we can see by this one example. For example, I have taken a set like this: 2 comma 4, then 4 comma 6. Now if we find 2 minus 4, it's equal to minus 2. That is 2. Now if we find 4 minus 6, that is also minus 2. That is 2. Now if we find 2 minus 6, it is equal to minus 4, which is also 4. Now all of them are even numbers. So it supports the transitive. So we can say that it is a transitive relation. Question number 9. Now it is given a set of relations like this. Set A is given as x belongs to integers 0 less than equal to x less than equal to 12. Now we have to show that first part we have relation R is equal to, we have an ordered pair of A comma B such that mod of A minus B is a multiple of 4. we have to show this is an equivalence relation. That means we have to show it satisfies all the conditions symmetric, reflexive and quantified. Now the set A is given like this, that is from 0 to 12. That means the ordered pair of set A is what? 0, 1, 2, 3 and up to 12. These are the elements of the set A. I am going to start. For example, if we take two elements from this set A, we have to find A minus A. That means now I am going to check for the reflexive nature. For example, if I take an ordered pair like this, A comma A belongs to R, then value of A minus B, which is equal to A minus A, which is equal to 0. And 0 is multiple of 4. Clear? So for example, if I take any ordered pair 2 comma 2 belongs to R. Now it becomes 2 minus 2, which is equal to 0, and 0 is again the multiple of 4. So it satisfies the reflexive nature. So relation R is reflexive. Now second condition, you have to check for now symmetry. Let A comma B belongs to R. It means that A minus B is a multiple of 4. And if I take opposite, that is B comma A belongs to R, then it becomes minus of A minus B, which is equal to mod of minus A plus B, which is equal to mod of B minus A. So it is also a multiple of 4. So we can say that B comma A also belongs to R. So relation is symmetric. Now I am checking for the quantitative nature. Now let A comma B, B comma C belongs to the relation R. Then we can say that A minus B is multiple of 4. Similarly, B minus C is also multiple of 4. So, from here, if we find A minus C, it can be equal to A minus B plus B minus C. We have to add both of them, and we get A minus C. So, A minus C is also multiple of 4. Here, so R is quantity. For example, I will take a case for the quantitative. I am going to explain it. For example, I will take some components, for example, of this set 1, 5 and 9. I will take A as 1, B as 5 and C as 1. Now if I find the value of A minus B, so it becomes 4, which is automatically multiple of 4. Now I am going to find B minus 6, which is equal to 9 minus 5, which is 4, which is also the multiple of 4. Now I am going to find 10 minus 1, which is equal to 8. And this is also the multiple of 4. Now it is obvious that it is 1. Now next question, second part of this question. Now in the second part, the question is like this. The relation is given as set of ordered pair A comma B such that A is equal to B, and we have to check whether it is an equivalence relation or not. So for the reflexive it is obvious. for any element A belongs to A, we have A comma A belongs to R. That is A is equal to A. So we can say that R is reflexive. Now I'm going to check for the symmetry. Let A comma B belongs to R. So if A is equal to T, then it means what? B is also equal to A. So in case of symmetry, we have A comma B belongs to R and then B comma A belongs to R. So we can say that relation is symmetric. I'm going to check for the transitive nature. Let A comma B belongs to R and B comma C belongs to R, and we have to show that A comma C also belongs to R. Now A is equal to T and B is equal to C. So it means that A is equal to C. That means if I take an example, 1 is equal to 1, this is A and this is B. And B is equal to C, that is, here it is 1, so it is 1, so it is also 1, so 1 is also equal to 1. We can either take the example not only of 1, we can take 5, 6, so every term we have the same term. So that means we can say that A comma C also belongs to R. So R is prime. Now here all the three conditions are satisfied: transitive, symmetric and reflexive. So ultimately we can say that relation R is an equivalence relation. If in the sense we have to frame that, so I think it is not important. The next one is the theoretical one. So in the exercise 1